Synchronous motor, construction and working. Hey everyone. Welcome to your channel name. Today, we're diving into one of the most important machines in electrical engineering, the synchronous motor. We'll explore its construction and working principle in a simple and engaging way. Let's get started. Rocket, Section 1. Introduction, background animation of motor operation. Did you know that a synchronous motor and a synchronous generator, alternator, have the same construction? The only difference is that an alternator generates electricity, while a synchronous motor uses electricity to produce motion. Sounds interesting? Let's break it down. Section 2. Construction of a synchronous motor. Visual breakdown of stator and rotor components. A synchronous motor consists of two main parts, the stator and the rotor. Stator, stationary part, built with a cast iron frame that supports the stator core. The core has slots for housing armature conductors, made of laminated steel sheets to minimize eddy current losses. Equipped with ventilation ducts for cooling. Contains a three-phase distributed winding, powered by a three-phase AC supply. Small diamond 2. Rotor, rotating part, carries a field winding, which is energized by DC supply through slip rings. Checkmark salient pole rotor, used for low-speed applications, e.g., hydroelectric plants. Checkmark non-salient pole rotor, used for high-speed applications, e.g., turbogenerators. Most synchronous motors use a salient pole rotor. Section 3. Working principle of a synchronous motor, animated explanation of torque production. Now, let's see how a synchronous motor works. Checkmark Step 1. When three-phase AC power is supplied to the stator winding, it creates a rotating magnetic field, RMF, at synchronous speed, ns equals 120 fpn_s equals frac 120 f p, where f is frequency and p is the number of poles. Checkmark Step 2. This rotating magnetic field interacts with the rotor poles. However, since the rotor is initially stationary, the like poles, nn, ss, repel, and unlike poles, ns, attract, creating alternating torques. Checkmark Step 3. Due to these rapidly reversing torques, the rotor fails to start on its own. Pushpin conclusion. Synchronous motors are not self-starting. They require an external method like induction motor startup damper winding a separate prime mover, and that's how a synchronous motor is built and how it operates. If you found this video helpful, don't forget to like, share, and subscribe for more electrical engineering content. High voltage battery. See you in the next video. Clapperboard, outro animation, channel logo and subscribe button. This version is more concise, engaging, and optimized for AI voiceovers while keeping it clear and informative. Let me know if you'd like any refinements. Rocket high voltage.